Welcome back. Today we're going to pick up where we left off last time on statistics. So let's take a look at error. In this case, we're going to look at margin of error. If Timmy has a 10% chance of falling off the roof, with a margin of error of 5%, his actual range of chances in falling off the roof are 5 to 15%. So all the margin of error is doing is saying, like, okay, so I know that it's going to be this value or a given amount less or greater than that value. And a 15% chance is just as likely as a 10% chance, as 11, as 9%. Anything within this range is equally likely. It's just that 10% is the middle term. So we put the margin of error as whatever it goes to be the maximum range of possible values. So let's scroll down then. So let's take a look at absolute error versus relative error versus percentage error. If I predict 30 rainy days a year and it rains 50, what can we say about error? Well, the absolute error is what I predicted minus what actually happened, right? That makes sense. It's just the value of the difference. The relative error then is finding the decimal that represents this as compared to the actual value. So my error divided by the actual value, we get negative 2 over 5, which would be negative 0.4. And then percentage error would then just be times 100 to get negative 40%. So my percentage error was negative 40%, and that corresponds to a absolute error of negative 20. So these are relatively simple. I would just memorize what those terms actually mean and the formulas associated with these errors, and you should be good to go. So on to probabilities. There is a 20% chance of Lucy crying and a 30% chance of Bob crying. So maybe this is a babysitter or something. What is the probability of only one of them crying today? Well, the probability of one event or another without conditions is the probability of one plus the probability of the other minus the probability of both. The probability of both of them happening would be multiplied. So 20% and 30%, multiply these together and you would get 0.06. And then we had 0.5 here. So 0.5 minus 0.06 would give us 0.44, which is a 44% chance. That's the chance of one or the other occurring. And then we have conditional. So try to see the difference between these two. For Jill to mow the lawn, Dane must pay $20. There is a 10% chance that Dane will pay, and if so, a 20% chance that Jill will just run away with the money. So for Jill to do something, Dane must do something first, right? That's what's occurring here. So there's a conditional probability here. She can't run away with the money if he's never given it to her. So that 20% would become irrelevant. So, what is the probability of Jill mowing today? Well, that would be the conditional probability of D and J happening, right? He has to pay, but we're having her mow. So remember what this 20% chance correlated to. This was the chance that she ran away. If there's a 20% chance she ran away, then there's an 80% chance she would mow. So 0.1 times 0.8 would be 0.08, which is equal to 8%. So this is the percentage chance, or sorry, this is the probability, this 0.8 is the probability that Jill will run away, or that Jill will mow given that D did pay her the money. So just be careful with how these are worded. That's really the most difficult part of probabilities, is interpreting these word problems correctly and pulling the right values. And then being able to recognize a conditional versus non-conditional, right? Dane must pay before Jill even has the chance to mow or run away, versus the previous problem, which is there's a 20% chance of this happening and a 20% chance of this happening, or a 30% chance of this happening, and they're completely unrelated. Whether Lucy cries or Bob cries are completely independent events. And with that, we should be good to go. With the probabilities, remember that there is a lot more formulas than I just went over. I just went over one example of independent and one example of conditional. I have listed the most common ones that you will see. And then, as I've noted in other videos, this probability of A and B, as well as this one, do not mean the same thing as the non-conditional P, A, and B. So make sure you do differentiate between these two, because they do not mean the same thing. With that, we're good to go.